Okay, so this is part 2 of the 6-5 video, and now we're going to take a look at taking the root of a complex number in polar form. Now this is not something that we are able to do with our complex numbers in rectangular form. It has to be in polar form. And that's one of the useful things of polar form, is that it allows us to take the root of a complex number. So if we have a complex number, let's say w, and we're taking the root of it, this is what we'll be doing. We'll take the nth root of the radius, and then we'll divide the angle by that, but we also have to have this plus 2 pi k thing here. Okay, and so where our k value is all the way to n minus 1. So if we're taking the 5th root of this complex number, then we would go all the way up until 4. So let's go ahead and get into some examples. First we have, we want to find all the 4th roots of 16, or the radius is 16, and then cosine of 120, I sine of 120. So we want to write our roots in polar form as well. So let's go ahead and get started. We're going to just write this in general. So I have z of 0, which will be my first one, and that's the 4th root of 16, cosine of 120 plus, and instead of 2 pi times k, we'll use 360 since we're working in degrees. And this is 360 times 0. That's our first root. We're plugging in 0 for k. And divided by the root 4 plus I sine 120 plus 360 times 0 over 4. And for these questions, a lot of times I like to set them all up first, and then we'll evaluate them after. And since we're taking the 4th root, we'll go all the way up until z of 3. So I'm going to set up all my problems here. So we're dividing all of them by 4. And inside we're doing 120 plus 360 times 1, 120 plus 360 times 2, and 120 times plus 360 times 3, and then the same thing over here. And now we're just going to evaluate these. So the 4th root of 16 is 2, and then we have cosine, and 360 times 0 is 0, so 120 divided by 4 is 30, plus I sine, and then we have same thing over here, 30. And it said to leave our roots in polar form, so this would be one answer. And then we have 360 times 1 is 360, plus 120 divided by 4 is going to be 120. And 120 plus 360 times 2 divided by 4 is going to give me 210. And then we have cosine 120 plus 360 times 3 divided by 4. We have 2 cosine 300 plus I sine 300. And those are our 4 roots. Okay, so we're going to have however many roots we have here. However many roots we're taking the root of. Okay, so that's how we're going to do these. Let's take a look at the next one. Now this is always a little bit confusing because we want to find all the complex roots of 8. And what that means is 8 is written in the form of a plus bi. 8 is the same thing as saying 8 plus 0i. So what we're going to do then is we first need to rewrite this in polar form. So 8 real, 0 imaginary is out 1, 2, 3, 4, 5, 6, 7, 8 right here. So theta is 0. My r is 8, and I want to find all of the cube roots of 8. So my n equals 3. So since we know what it is in rectangular form, now that we have this information, we can write z in polar form. So r is 8, and then we have cosine of 0 plus I sine of 0. So now we can go ahead and evaluate this. We want to find z of 0, z of 1, and z of 2. Since we're taking the cube roots, we stop 1 before that. So the cube root of 8, cube root of 8, and cube root of 8. Again, I'm going to set them all up. Cosine of, and I'll just put parentheses, and I'm going to set all my fractions up. And we're starting with 0. And really you can work with radians or with degrees. It really doesn't matter. Since we did the last one in degrees, I'll stick with degrees. So plus 360 times 0, 360 times 0, 360 times 1, 360 times 2, 360 times 1, 360 times 2. And now we can simplify those. 360 times 0 is 0 plus 0 is 0, divided by 3 is 0. So we have cube root of 8 is 2 cosine 0 plus I sine 0. And here we have 2, and 360 times 1 is 360, divided by 3 is 120. And then here 360 times 2 is 720, divided by 3. It's going to give us 240. And the question is asking us to write it in rectangular form. So I need to simplify these to rectangular form. Cosine of 0 is 1, sine of 0 is 0. So 2 times 1 is 2, which we knew that one. We knew the cube root of 8 is 2, but it actually has 2 other imaginary roots. So we have cosine of 120, and sine of 120 is root 3 over 2. This is 1/2. So times 2 would give us negative 1 plus I root 3. And the other root is going to be negative 1 minus I root 3. And what's really interesting is that we have these relationships here. These are complex conjugates of one another. And if I have this root, I'm always also going to have this root. Okay. Now, what's interesting is that these are the same answers you would get if you solved the equation x cubed minus 8. So if you solved this equation, or you factored it, then these are all the answers that we would get. Okay. So if I factored this, this would be, we would have x minus 2, and then we'd have x squared plus 2x plus 4. and this is the root from that, and these are the roots from that. So let's go ahead and move on to the next section.